Welcome. We will continue blocking and confounding in to the power k factorial design. And in last class, what we have seen that I have discussed what is blocking in to the power k design, and then we also discussed what is confounding in to the power k design, and we also discussed defining contrast, which will help in assigning different experimental combinations or treatment combinations to different blocks. Okay. So, what we have seen basically in the first case, you have seen that how the blocks are used as replicates, and when every block is able to accommodate all the treatment combination. In case of confounding, you have seen that even every block is not able to accommodate all the treatment combinations. So, you found that there are some of the effects parameters which are confounded with the blocks, and usual guideline is that it should be the higher order interaction that should be confounded. And then we have used defining contrast, where I said that defining contrast is alpha 1 x 1 plus alpha 2 x 2. So, like this your alpha k x k if there are k number of factors, and x I basically can take values 0 or 1, and depending on the from the contrast design matrix you will find whether this effect is at low level or high level, and alpha I will become 0 or 1 again if it is present, if that particular ith factor is present in the defining in the effect to be confounded, and or absent in the effect to be confounded. Depending on that, 1 or 0 value will be assigned to them. So, and then with in a 2 to the power 3 design case, I have shown you that how you will require 8 runs. Suppose you have insufficient materials, you can go for only to the power 2 runs per block. So, that means 4 runs per block. Then what are the treatment combination starting from 1, then A, then B, then AB, then C, then AC, then BC, then ABC. So, these are the 8 treatment combinations. Which are the treatment combination will go to block 1, and which are the treatment combination will go to block 2. So, using this concept like L equal to if effect to be confounded is AB, ABC to be confounded with block, then we have seen that 1 AB, AC, BC will go to block 1, and A, B, C and ABC will go to block 2. How? You have used this, you have written first you find out the value of L, and that you write in terms of L mod 2, or I can say A mod 2, no problem if L is just to avoid this. For example, we have seen in order to, if ABC is confounded, alpha 1 equal to alpha 2 equal to alpha 3 equal to 1, and in that case, and if I am interested to find out the what will be which block it should the treatment 1 combination 1 will be run, that will be written like this. So, alpha 1 x 1 plus alpha 2 x 2 plus alpha 3 x 3, where alpha 1, and in one treatment combination all will be at low level, plus 1 0 plus 1 1 0, then this will give you 0 value. So, this value is 0. Now, its equivalent write up will be 0 mod 2. So, suppose if we want that what will be the block for, so that means what is the block for A, then in that case it will be 1 into 1 plus 1 into 0 plus 1 into 0, which is 1, and this can be written that 1 mod 2. So, these two, that means when you just see that whether it is going to 0 or going to 1. So, all those treatment combination where this value is 0 will be put with block 1 and combination with 1 will be put with block 2, and in this way you are basically defining the treatment combination for two different blocks. Okay. So, that is what we have discussed so far, and geometrically you see that that 1, then your this one is AC and this one is AB and this one is BC. These are all with block 1. So, run in block 1 and others run with block 2. Okay. This is the first one. So, another concept is that the same thing, that how which treatment combination will go to which blocks, that can be done using the principal block concept. So, the block containing the treatment combination is 1 is called principal block. The treatment combination in this block have a useful group theoretic property, namely they form a group with respect to multiplication modulus 2. This implies that any element except within bracket 1 in the principal block may be generated by multiplying two other elements in the principal block on modulus 2. Okay. So, what we mean to say, this is our first block, because this is the principal block, it contains 1. Now, if you multiply the other treatment combinations here, then ultimately you will be getting another treatment combination in the same block. Like if you multiplied AB with AC, you will be getting BC. If you multiply with AB with BC, you will be getting AC. If you multiplied AC with BC, you will be getting AB. Okay. And you will get what I mean to say, that as you have 1 AB, AC, BC, these are assigned to the first block. Now, if you multiply it with any other treatment combinations which are not in this block, so what will happen? You will get the treatment combination in the other blocks. How it is? Suppose in the first principal block 1, then we say AB, then AC and BC. So, the other treatment combination, for example, B, if you multiplied with B everywhere, what you are getting here? You will be getting here B, AB square, it will give you ABC will give you ABC, B square C will give you C. So, see that A, B, C, A, B, C, which are the treatments that are not assigned to principal block. So, they will go to the another block. So, that sense, even if you multiplied this with suppose A, you will also get the same thing. Okay. So, this is the concept. And another simple one, the first one what I explained, but if you see here, you see that we say that effect to be confounded with block. So, when you create this algebraic matrix, you will also get the contrast for ABC, and here you obviously in all the columns you will say you will get plus or minus sign only. So, now here the minus will be assigned to block 1 and plus will be assigned to block 2. So, there will be only minus plus and equal number of minus and equal number of plus. So, minus treatment combinations will go to block 1 and plus treatment combination will go to block 2, obviously with respect to the effect to be confounded. If your effect to be confounded is AB, then the assignment of block will be different. So, that means this plus 1, the first one will go to block 2, second, third will go to block 1, then again block 2, then another to block 1 and block 2. Now, if you say that the block which contains the treatment combination 1 within bracket 1, this is the principal block. Then our principal block will be here. If AB is confounded, then this is means 1, then AB, then C, and then ABC. Okay. So essentially what I mean to say here, instead of ABC, if your effect to be confounded with block is AB, and then the principal block will contain 1, then your AB, principal block will contain 1, then AB, then C, and then ABC. So what will be the another block? This is your block 1, let it be block 1 goes to this. Another block you multiply with A, then this will be A, this will be B, this will be AC, then this will be BC. You see, this will go to block 2. So that means effect to be confounded is very, very important, and accordingly the assignment of the treatment combination to the blocks. So if AB to be confounded, this is the case. If ABC to be confounded, then you have already seen that ABC to be confounded, then you have seen that this is 1, AB, AC and BC, that is block 1, and another one will be others one AB, C and ABC, this is your block 2. So with this background, let us see one example, and let us estimate the effects, as well as you see that whether which of the effects are significant, which of the effects are not significant, develop ANOVA table like this. So we have 4 factors A, B, C, D. They are temperature, pressure, concentration of formaldehyde and stearing rate. And each with 2 labels. So you know that there will be 2 to the power 4 means 16 treatment combinations, and you can develop this algebraic matrix A, B, C, D, and that plus minus combinations, all those things are known to you. What happened? You take the first column, minus plus minus plus minus plus, second column, minus minus plus 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 plus, then third column, that is 2 to the power j minus 1, 3 minus 1, 2, 4 minus 4 plus 4 minus 4 plus, like this. And you also know that how the run level will be defined with reference to that A, B, C, this kind of these alphabets. And suppose, and these are the run level, and suppose you have done once, because you have the restriction with source restrictions and all those things. So one runs, other I can 1 replications. But another restrictions is that you cannot do it with 1 block, you have to do it with 2 blocks. The reason is you cannot go for 16 runs, experimental runs in 1 block. So here block is the resource. So you require let 2 blocks to be used. So that means under each block there will be 8 runs. So 8 different treatment combinations will be allocated to block 1, another 8 treatment combinations will be allocated to block 2. Okay. And this is what is this is the geometric representation of this 2 to the power 4 design, and this is what is our this, and suppose what will happen, there will be 2 cases. So one case will be when you have you are going for block only 1 block, another case will be going for 2 blocks. So although this example is for 2 blocks, but we have seen this earlier with only in case of single replicate with one homogeneous set, and that time the filtration rate, which is the response variable, what are the data obtained with reference to different experimental or treatment combinations are like this. These are the values. Now, as we have the restriction with blocks also, so we are using two blocks, and then in that case we are assuming one more important concept, that we are saying that if you run in block 1 using block 1 or using that batch of raw material or run with block 2, there will be a difference. What is the difference? Here we said that in addition, suppose you want to introduce block effect, so the utility blocking can be demonstrated. In that case, when the two blocks of raw materials required to run the experiment, one of them is much poorer quality, and as a result all responses will be 20 units lower in this material batch than the other. So, I am repeating this case. First one, you see these data points. So, we have 2 to the power 4 design. So, we have 1 A, B, AB, C, AC, BC, then your ABC. So, like this, ultimately you will go to ABCD. So, 16 runs. Suppose you have sufficient raw material in such a manner that every batch will be able to accommodate this 16 runs, but you don't have more than that. So, one batch is used and your response variable is measured. This measurement, like this first one is 45 is the response, second one is 71. So, like this 96 is the last one, this is the response. Okay. Suppose you want to conduct the same experiment another time, let it be, but when your raw material is, the batch is not sufficient enough to accommodate all the 16 runs, you require to do with 2 batches of raw materials, because only 8 treatment combination can be accommodated per batch, BATCH. So, as a result, the blocking concept is coming into picture. So, that means each block batch here represent one block. So, we use 2 block 1 and block 2. So, that means 2 batches of raw material. So, here you will be having 1 to like 8 runs, here also you will be having 1 to 8 runs. Then you will be having the response values y, here also you will be having the response values y. Suppose you further assume that the original batch is also available and it is assigned to block 2, it is called block 2. And block 1 is a much poorer one, which is basically taken from maybe some other supplier, and then what happen, it has effect because it will reduce the response values. So, what is the reduction? Let it be the 20 units reduction because of poor quality. So, as a result what happened, the response will change. You see here, in the block 1 treatment combination 1 it is 25, but earlier example it was 45. So, 45 minus 20 that is 25. So, this block is poorer than block 2 and that block effect is 20 units. That means if you use block 1, that means batches of raw material representing block 1, your response will be 20 units less, and that is what is the block effect. When purposefully we have said first the block effect is 20. And suppose these are the data. Now, your question is first question is that how do we assign these 16 runs to block 1 and block 2, 8 per block. So, that concept we have already discussed. We said that you go by defining contrast, or you first find out which effect to be confounded, and then that effect find out the contrast for that effect plus and minus sign, and then what you do, then all block 1 will go to plus minus sign and block 2 go to plus sign, and that sense, okay, or using defining contrast you find out. So, you using that you find out that this 1 AB, AC, BC, AD, BD, CD, AB, CD all will go to block 1 and others will go to block 2. Block 2 means the original batch of raw material which is of superior quality than block 1. Okay. So, what will happen to the estimates? You see the regression coefficient here. So, we have A, B, C, D, all those A, B, C, D, all everything that affects, and the regression coefficients you have seen, and you see that earlier example, that example we have I think we have actually explained in some previous lectures, where these two blocks we have not used, but with single replicate we explained, and there you see that all the effect values they are same. And there are some squares, but the difference is that this block ABCD and block are confounded here. Please see this red arrow here, it is confounded. Now, in previously you found out the ABCD effect is 1.375. Here, as ABCD and block both are confounded, the effect estimate is basically what happened, it is minus 18.625. This is the effect. So, what is this? What is the why it is happening? Because block and ABCD, that interaction, they are confounded each other. They are inseparable. But in this example, that the design is made in such a manner that the block effect beforehand we assume that it is 20. So, now then what is the ABCD effect? If the last row here it is talking about both the effects together, and as we already know the block effect is minus 20, then block effect plus effect of ABCD is this. So, block effect, that is minus 20 plus ABCD, this confounded, and this is 18.625. So, then what is ABCD effect? Is 20 minus 18.625, which is 1.375. This is what you have we have obtained in earlier example using this data set, single replicate case. So, with single replication we have seen that the error cannot be estimated, because we do not have any observation left, no degrees of freedom for error. Here what happened, plus we have included one more thing, that is what we are saying, that the two blocks are used. So, one of the higher order interaction here, the highest order interaction ABCD is confounded with the block here. So, ultimately one more restriction is imposed and error is not estimated here. So, then what you will do, you will basically follow the same way we have done earlier, that you find out the relative contribution in terms of percent contribution, and then negligible contributors can be neglected. Then develop a probability plot for the effects and find out the effect which are far away from the straight line, and those effects will be considered as significant. and then other effects which are basically lying on the straight line in the PP probability plot, all those will be neglected, and their effect will be considered as error effect, as error measure, and then the traditional ANOVA that F test all will be done. Okay. So, for that what you require to know, also you require to know in this case what is the block effect. So, it is similar, it is the same thing, you just find out the block total. So, you have two blocks 1 and 2, find out the average for block 1 and average for block 2, and then the effect of the block will be the difference between the effect. So, y bar block 1 minus y bar block 2, which is minus 18.625, which you have seen here, how we have computed the block effect. Okay. Now, again SS block you can find out that there are two totals for block 1 and block 2. So, those will be squared, and obviously that will be their average will be computed, and then finally it will be the corrections will be corrected factors value will be subtracted, and you will be getting this value, and this is this value. Okay. So, that means for all A, B, C, D everything you using contrast, you find out the effects. For block use this, find out the block effect is confounded with ABCD effect, also find out SS block using this formula. Formula is sum of BI by VI square by the some multiple of n minus y dot square divided by the sum of all means divided by all the observations. These are the concepts already we have discussed. So, you see the relative contributions of A, B, C, D everything, the percentage contributions is written here, and these are the effect values. So, when you construct a probability plot of the effects value, you will be getting something like this, and here you see that most of the effects values are lying on a straight line, and there are few like A, C, D, AD and AC, they are away from the straight line. So, that means they are different, they are not, they are significantly contributing, and as a result see A, C, D, AC, AD plus block is already there, and then error will be rest of the that effects which are not significant, their total sum square is taken, and this is the error sum square. Now, you are in a position not only you know the effect of block confounded with ABCD, but also you are in a position to know what is the error sum square and the resulting degrees of freedom for error, and you are in a position to do F test for to see that whether these effects are significant or not, and you doing this, you see you are getting F values, very high F values, and all these values are, all these effects are significant. Now, you can say that in this particular exam case ACD, AC and AD, they are significant parameters, and if you want to do subsequent analysis, those things to be taken into consideration. So, now we want to see that suppose two blocks are not sufficient. Means what I mean to say, you want to do suppose 32, suppose you have 2 to the power 5 design, let it be like this. So, you require 1 to like this 32 experimental runs. If you want to use two blocks case, so then each block will contain 2 to the power 5 minus 1, that means 2 to the power 4 runs. Suppose this is not possible, you have to use something like this 2 to the power 5 minus 2. That means what I mean to say that means 1/4 of 32, so 8 runs. So, 2 to the power 5 minus 2, 8 runs, means each block can accommodate only 8 runs, not 16 runs. So, if one batch of raw material can accommodate 32 runs, you do not require 2 blocks. If one batch of raw material in this case, or one type of resource can accommodate here in with difference with the 16 runs, then you require 2 blocks. But if that will not happen, then what happened? The next is that I say that to the power p blocks case. So, you have to go to the power 1, 2 blocks, to the power 2, then 4 blocks. So, 4 blocks case you have to go. So, 4 blocks means each block will accommodate 8 runs. So, this is that is why this is known as, here we are saying that to the power 2 mean to the power k minus 2. This is what is the observations per block. When there are k blocks and you want them in when there are k factors and you want to use 4 blocks, because your situation is such that only 4 blocks can accommodate this, at least 4 blocks can accommodate. So, in that case each block will contain to the power k minus 2 observation. Okay. So, see in such cases what happened when we are using 2 blocks, that time we are saying to the power k minus 1, that means 1 by 2 into to the power k. When we are using 4 blocks, we are saying 1 by 4 into to the power k. So, like this. So, here 2 is very important, here 1 is very important. In this case what happened when you are using 2 blocks, that one higher order interaction is confounded, one higher order interaction is confounded. But here what happened, 2 higher order interaction will be confounded. So, every confounding case will give you one defining relations, defining contrast per effect to be confounded. So, when there are 2 higher order interaction confounded, so you will have two different defining contrast. So, here if we say it is L, here it will be L1 and L2. So, L1 with one effect, L2 with another effect. Okay. Now, see, for example, consider to the power 5 design with 8 runs in each block and 2 effects. What are the 2 effects? A, D, E and B, C, E are confounded with blocks which have 2 defining contrast, L1 and L2. Obviously, A, C, D means, suppose if I say A is x1, D is x4, E is x5, then L1 is x1 plus x4 plus x5. So, in this lecture, first I will show you how the 4 blocks case will be constructed. Okay. So, let me read out. It is possible to construct to the power k factorial designs confounded in 4 blocks of to the power k minus 2 observations each. These designs are particularly useful in situations where the number of factors is moderately large and block sizes are relatively small. Situation is you have more number of factors, but your resource is less in amount, like raw materials per batch can accommodate less number of runs or less number of experimental runs can be completed. Thank you very much. Have a nice day.